Now we are on the last part of the finger classification dataset of Kaggle, and probably it's the most important and the most complicated part that I will try to explain in an easy way. But you need some kind of a little bit of experience in Docker. If not, probably when you get some troubles, will be a little bit dizzy, or you will be scared about the errors and you will not fulfill your end, that is training and deploying a model. So let's get started. We know that we're using the Kaggle fingers dataset and the specification of our dataset. The first thing is to install some libraries. We will use SageMaker debug to debug some information about our training and our model protobuf, because we need protobuf using SageMaker 1DB, because um, practically these things here are because legacy compatibility, that when I faced some problems when I was training, but in the end, I think only you need is SageMaker debug if you are on the instance on SageMaker. So after installing everything, I decided to restart the kernel, because when you start installing libraries, it's recommended to restart everything. The next thing is that we will be trying to put over the bucket. A bucket is like a, a hard drive over the internet, in simple examples. And so we'll try in these parts to do some things about uploading data. But first, we'll try to import SageMaker. Boto3 is the common library for SageMaker. Also, we're using PyTorch, bytes.io from IO for manipulating string bytes, zip file, because there are several ways I demonstrated on the previous video that you can do it using command line interface commands like AWS CLI, AWS S3 uh, copy and the source and destination of the information. But here I'm using zip file and Boto3 to upload everything. Finally, this one is for the tuner, the parameters. We will use the hyperparameter tuner and some variations like the integer parameter, categorical parameter, or continuous parameter. First, we check and instantiate or the name of the bucket that we are using. In my case, I create a bucket named SageMaker instance bucket and get the default execution role. For me, is pretty enough to do the basic things over SageMaker, and we will use the session to manipulate below and do some things. As I told you, you can use this command for uploading to the, for downloading or loading. In this case, we are copying from this bucket to the current instance in SageMaker. We will unzip it, and this part is a little bit longer, so I will go to the end. Okay, and here it comes. Okay, that's the same thing, and here I am uploading the file. This thing is because it was a paid course and they wanted to download and upload everything, but in the end you decide what you are trying to do. Practically, the best way is to upload to the bucket and load it to the instance in SageMaker, in the training instance, I mean. The next thing I did here, this part is just for loading, as unzipping and uploading each image over the bucket. You can do it in that way. It handles too much time, or you can do it using the CLI interface as stated before. Because our bucket, it has the SageMaker instant bucket, and I unzipped the finger sorted data sets Here is the path over it. So I am inserting my default SageMaker bucket. Below, we will be trying to do hyperparameter tuning. That's the first thing that you're trying to do, because you will try to loop over all range of models, all range of hyperparameters, and run multiple training jobs over the time, probably 4 or 5. In my case, I run a little bit less because it's painful for me. It's just, of course, I'm not monetizing even the channel, also over SageMaker in that model. I'm not doing anything for a company, for example. So the first thing before doing hyperparameter tuning, you have to specify the metrics and the objective. In that case, because we're doing classification, we will try to minimize, sorry, and the objective metric will be the validation loss. When you're doing these things, uh, we'll see below that the kind of way that SageMaker can monitor your training jobs is via a regex. So a regex is a regular expression, and we will, of course, we will monitor this word validation loss. That will be a number here. So we'll start for numbers and also decimal points from beginning to the end. Here we will try to hyperparameterize the learning rate, the batch size, and the epochs. Sorry. And you will note that I put the batch size as categorical just to play, but you can also put the categorical as an integer parameter that runs between some ranges. Well, in that case, I do it in that way. So there are continuous parameter, categorical parameters, and integer parameters. Let's see here. You will have a mean value, max value, and the scaling type. Depending of the kind of parameter that you are using, you have different scaling types. For example, here, well, scale the default is auto, but you can get linear logarithmic or reverse logarithmic. Here, where we go? Okay, here comes the magic. So for understanding this part, I will make a stop here and we'll try to explain a little bit how SageMaker and also all those cloud uh, technologies works. In the case of SageMaker, in the case, we will be looking about this. When you run an instance of training, in that case, or processing jobs or anything, where practically you are trying to do is to load Docker image from the Elastic Container Registry, yours or the default images that are on these SageMaker repositories over AWS. Inside, you will have different kind of structures. We will look over this. Imagine that this is the training job over the Docker container. So you will have different kinds of folder and different kinds of information that could navigate inside. That's the structure of the file system inside the Docker container. You will have, for example, opml model that will allow the model to be, or opml input, opml output, or opml model, as I told you previously. So let's move and see how is composed the file system over SageMaker. You have here, for example, when you load something, you will load over the channel data. The channel data could be training, could be validation, could be test. You can put it, and we will see later. And the models and the finished models go here, and if you put here, SageMaker try to copy to the directory that you sourced on the parameters, or or in the default bucket that will be instantiated the model. Here on the output, you will see some failures or output data that you can pull out, and the configuration of the hyperparameters goes here, but you can configure as you see when we be back on the first notebook that we are discussing, that you can put the parameters as obviously hyperparameters of the training job. As they say, there are some input buckets, no bucket, input information that is put inside the file system, and you can read here, or the output are handled here on the model and the output folder. So everything you put here goes out. And practically, training jobs over Docker are training jobs, processing jobs are Docker images. So this is the way that you can. You can also validate your Docker ECR over SageMaker before trying to do in your training job or looking for default containers. But in that case, we are trying to load a PyTorch container that the source directory of our file is on the code folder, and it's called hpo.py. Let's see here, hpo.py. Do you remember that code on the previous video? Well, that code practically I know it works because I tested previously. So that's a main problem when you start SageMaker. You probably start doing your training job and it fails, and it will cost a little bit you money. But if you test everything before you are going to put it here, you will be fine. Okay, let me see if I put some functions of the modeling. No, just only the training part and not the inference parts. We will see later. So for training, we are passing those arguments, and the learning rate, the batch size, the epochs. We can pass this information too, but I decided to eliminate. We're passing the model there, training channel, and if we're using GPUs, the GPUs that we're using. Okay, and finally we parse the argument and launch it over the main. That the main is practically doing the training and finally saving the training over the models there. And usually is the optimal model when you use the environmental variables. There are some environmental variables over SageMaker. You can find it over the internet, but let's say that everything is okay. So you put here the code previously tested. I am using PyTorch 1.8. You can use every kind of PyTorch version. Just remember that you have to test everything previously. I'm using the 3.6 version of Python, and here I'm using an ML-M5 large machine. So for machine pricing, you can go here and look over the training, and you can see the ML5 large machine is one of the standard instances, use 8 GB of memory and cost 0.115 the hour. And if you're using less, it will cost the fraction of the hour. So you only pay of what you are using. That's why sometimes SageMaker is a little bit inexpensive. So for the role, I'm using this kind of role, the session, and the base job name is called EST, or of estimation fingers. Those are the hyperparameters that will be cloned on this where is on the hyperparameters file. And this is the estimator. It's just how we call the model. But for using the model, the estimator, and doing multiple trainings over the estimator, you can do it via hyperparameter tuning job, and you can check everything about the arguments here. But practically, if you want to make it work, you have to put the estimator, the objective metric name, the hyperparameter range, the metric definition, how many jobs will be for the hyperparameter tuner. For example, there are 4 jobs. What kind of, okay, max parallel jobs. For example, I put 2, so it will run in batches of 2 estimators. For example, we'll go estimator 1 and estimator 2. Because we have 4 max jobs, we have 2 others pending to train. So in the first batch, we'll run 2, and if one of them finishes, then the next training job will try to start. That's because we specify this number here. If it will be 10, it will start by the first 2, and then the one that finishes start with a new training job. And in this, we can ensure that we are doing in batches of 2 the trainings only, and not all the batches all the time. That's why the way that the hyperparameter tuner is working is that they reuse the results to improve the modeling. And the objective type and the base tuning job name here. Let's see some examples here. And that's the final example of the tuning job for in Sagemaker. And you can inspect here something that I put on the notebook, that we are minimizing the validation loss and design MLFI large. Where is the model? Let's see what other things we can see here. Oh, this one is this one, 10 fingers. Okay. Okay, best training job. Our best training job was with these hyperparameters at the end. We will see later. Let's move over again. We'll start training and then finishes. We can get the best estimator of the tuner, hyperparameter tuner job, get the best estimator, and we load on memory the best estimator, and for the best estimator we got these hyperparameters. So the model will be on this submission directory, and we use those parameters for training our best model. When you are done, next, let's say that we want to reload the hyperparameters, we do it in that way. And finally, we will start to train in the model. But before we have to, that's not necessary, but it's a good way to do, is to put a profiler to look over some kind of problems that we'll be doing over the training job. For example, we can use it to check vanishing gradients. We see the utilization of the GPU, or if we are overfitting or overtraining. So there are some things that we can test when we are training, and we can measure it to look it later. Next, we try to load the profiler configuration, and in the end we try to do this hooking everything over Sagemaker. We'll run it over the training interval and the eval interval over these these times, and everything here that specified could be used on the profiler. Next, for training the model, I will use in the same folder a file that is called train model, same version, same machine, everything is practically okay. One thing that I didn't explain the previous step is that you can specify dependencies. For example, if you are using some other things that are not specified on the Docker container of SageMaker, you can also load it. For example, let's say now pandas is loaded. let's say GeoPandas. If you want to use GeoPandas, and then you can put it on a requirements file. The max runtime is how much time will run in seconds the machine. For example, this estimator will run if I enable this line 300 seconds, and the output path you can put an output path of the estimator to be. Finally, we'll fit the estimator over the training channel. So if you remember, we specify the channel here on the op ML data and the channel type. So the data will be on op ML data and training. Okay, let's see. And we will wait for the training to finish. One thing that we didn't check is what is inside the train model file. Let's see, train model. And if you see, the main difference here is that we have this. Let's see. Okay. Here I put the model function, the input function, the predict function, and the output function. That's because with this estimator that is not the hyperparameter tuner, because the hyperparameter tuner, we as you remember, we launched a lot of models and then use those models to learn from another and got a best model. And with the best model, we are launching an estimator to put it over and deploy the model over an endpoint. So that is used for the deployment of the model. No, the test part, no, the output function, the input function, the predict function, and the model function. You cannot specify them at all, but you always need the model function. So if you don't have the model function, it will not work. Finally, okay, when everything finishes, we can double check the training job name and the region and load the trial to keep and see the information about the profiler here, our training job. In my case, because I didn't train a lot of the model, you will see that you have 1 and 1 here, but in a good training job, you will see you have 125 over 1, not 1. And that if you see 1, you will have problem graphing the profiler. That in my case it was. Finally, you will load the analytics. The analytics are on the bucket. You will print where is the output of the information that you will try to load. And when you load everything, you will look for the profiler name that is called profile report, and you print or display the profiler report. You will see here that like the kinds of information that will give our profiler report. Practically some are useless for me because I'm not using the GPU, but you can see if you have problems of load balancing and recommendation that it could give you over the batch size if you are using a GPU. In my case, I didn't use a GPU. I didn't need it. And here is the duration of the training time and the percentiles, the 50 percentile and then 99, 95 percentiles. Those information are not present because I'm not using GPU, but if you are using GPU, you will be looking over the statistics. Finally, we can see here the trial over, and we will plot the tensors and the validation outputs. But practically, because I have only 1 point, you will see nothing. But in your case, you will have probably more. Next is the final part, the deployment of the model. You can look over the estimator and deploy the model over one instance using T2 medium. Let's see the pricing here. Deployment, training experience, real-time inference. The most cheapest one that we can use is ML T2 medium. That's why I select the ML T2 medium. the MLT2 medium, and finally, when everything is deployed, you will see that in the inference, first thing, you will have a model here, an endpoint configuration here. Let's see, I have two models. This one is the model. The model doesn't incur in cost, but the endpoint and the instance will incur in cost. And here you will see your deployed endpoint. When the endpoint is deployed, next we can do some predictions. For example, I try to predict over the endpoint. I will pass an image of type X image, and it spits out the classes, as I told you previously on the video talking about the training over PyTorch and the predictions. By default, it will only look or give you this kind of information, but if you want to look for rich outputs, you have to do your proper functions. And this is the information of the classes, the predictions. Well, this thing ordered just only that, and plotting the results of the image. So you will see here that you have a finger, two fingers of the left hand, and finally, don't forget to delete the endpoint. So practically that's all about SageMaker and training jobs, hyperparameter tuning jobs was the whole pipeline, and that's the basis practically of using SageMaker. There are some kinds of crazy stuff that you can do via workflows or pipelines that I will try to demonstrate later. But right now, I'm just looking about how to do the pipeline manually. So I think it covers everything about SageMaker. I hope you can uh, improve your machine learning knowledge about uh, the workflow of loading data, examining, and preparing the training script, and finally doing this thing over SageMaker, try to deploy something. There are some more things that you can see and use in SageMaker. I didn't talk about processing jobs here, and also um, batch transforms. Probably later I will talk about this, but that's the common way that you do training and deployment on SageMaker. So I hope those guys help you, and we'll keep in touch later.